All right. Is this working? Yeah? Okay. All right, everybody, welcome to Start Process PowerShell, Get Forensic Artifact. That was my little cutesy way to add some PowerShell to the title. As Rob said, I'm Jared Atkinson. I work for Veris Group's Adaptive Threat Division. We are a small consulting company out of Northern Virginia. A little bit about me. As he said, I worked in the U.S. Air Force. That's where I got my beginnings. I was a history major. The Air Force miscoded me as a computer science major, and I guess the rest is history. Before PowerShell, my favorite Microsoft product was Minesweeper, and so in 2015 at Black Hat in Vegas, I won the Minesweeper competition and won $2,000, so I'm a professional Minesweeper player, based on my definition. I'm the moderator of the PowerShell.com security forum, so if you have any questions about PowerShell security, whether that's offensive or defensive, please feel free to come out there and ask some questions, and we'll make sure we'll get you in touch with somebody that can help you. I developed PowerForensics, which is what we'll be talking about today, as well as Uproot IDS, which is a WMI-based intrusion detection system, and WMI eventing, which also works with Uproot. And then I do a lot of forensic artifact file format research. All right, so what is PowerForensics, right? It's, as a lot of you know, PowerShell is kind of, it's not really a new thing, but it's becoming more of a mainstay in the information security field. Most people are familiar with kind of the offensive purposes for PowerShell. A lot of people are working on how to defend or detect offensive PowerShell. But what people really have kind of been sleeping on, I think, is the defensive utilization of PowerShell. It was originally created to be a system administrator tool, and if it can do system administration in an enterprise, it could probably do some really helpful things as far as finding badness in your network. PowerForensics is a module, so PowerShell is very modular. You can write code and then import commandlets, which allow you to run the commands. And so PowerForensics is a module that's for live forensic investigations. PowerShell allows you to write modules in PowerShell, which is a scripting language, or in C#, which is what I chose to use for PowerForensics. It's a little bit faster, and it has a little bit better like class structure, things of that nature. One of my things that I wanted to do with PowerForensics is minimize the reliance on the Windows API. So I'm going to kind of go through how PowerForensics does that, how it parses all the raw structures, things of that nature. And then right now it currently parses NTFS data structures like the MFT, the USN journal, so on and so forth, and then a lot of like the Windows registry, the event log, and a bunch of other individual artifacts. So some of my design requirements, I wanted to be forensically sound. That's a very touchy-feely kind of requirement, I guess. One of the things that I was really looking at is not relying on the operating system because it can lie to you, as well as not altering any artifacts on the system or altering as little artifacts as possible on the system. I wanted to be able to execute on a live running system. I wanted to be operationally fast, meaning I could parse the MFT in seconds rather than minutes. And then I want it to be modular, so each individual commandlet is going to perform one function. For instance, I have invoke forensic DD, which allows you to read arbitrary bytes from a disk. And then I want that capability to be able to be leveraged into an MFT parser, for example. And then I want it to be capable of working remotely, right? So I want to be able to run this thing against a number of systems remotely, which we're in the proof of concept stage with that. For instance, if you use fresponse, which is a commercial tool, you can run this remotely. We also have a couple open source product tools that we're working on to help with that. All right, so kind of getting into the nitty-gritty of how PowerForensics works. Right now, the only Windows API that we're actually using is the create file API, and so we use that to get a handle to the actual disk to start reading bytes from it, right? And so you have to rely on the operating system to do that, and that's how we're doing it. Then we're using the file stream read method to, it's a .Net class that allows you to start reading those bytes from that handle. When I was writing all of the code for PowerForensics, I wanted to kind of give myself some visualization of how the structures work, so I made these pretty little posters. And so just kind of walking through the way that PowerForensics would work, let's say you're trying to parse the master file table. You would start with the master boot record, which is going to tell you the different partitions that you have on that particular disk. You would find an NTFS-based partition. And then you would go to the NTFS volume boot record, which is going to tell you how large that volume is. It's going to tell you where the master file table is, give you a couple pointers there. And then you're going to come to the master file table. I'm kind of going through this fast because I have a lot of demos to show. So the master file table is a metadata structure that has information about every file, whether that's a data file or a directory on the disk. And so it has things like all the timestamps that we associate typically with like the file system, last modified, last changed, last accessed, so on and so forth. It also has the name of the file itself, so like cmd.exe. And then it's also going to have, if it's a data file, a data attribute that points to where the actual contents of that file exist on the file system. This is what a data attribute looks like. There's kind of two different ways. One can be, the data can be resident within the actual MFT record itself if it's a relatively small, file. And then if it's a large file, the data is actually going to be non-resident, meaning that the MFT points to where that data is. And so in this case, we have a file that says hello world, and that's what that data attribute would look like. If it's a directory file as opposed to a data file, then whoops. This was the MFT resident data attribute, and this is the non-resident data attribute. And so the non-resident data attribute is going to have pointers. You kind of see over here, these data runs are pointers to where the actual contents of the file are stored on disk. In this example, this non-resident attribute is pointing to a non-contiguous file, meaning that the data is not stored contiguously on the disk, and so we have multiple pointers to where that data is. All right, so I'm going to go into like a kind of a demo that shows using PowerForensics from like a case study purpose. There's a guy named Ali who he goes by Binary Zone on Twitter. He's put out a bunch of kind of like incident response challenges online, and so one of what I'm going to be using is one of his incident response challenges. I highly recommend checking it out. So Binary Zone, there's a 0 instead of an O in zone. And if we could play the first video. And I'll kind of narrate it as it goes along and explain what's happening. All right. Oh, okay. So that was, I didn't realize it was playing. So can we go back to the beginning real quick? Sorry. I thought the mouse was your mouse, not the mouse in the video. Yeah, so this is just showing that I'm mounting a disk image using FTK, and so it's mounted as the H drive, so I just wanted that to be clear before we get going. Now I'm starting a demo, which this is just a PowerShell script which keeps me from having to type everything out, so there's no typos. So it's kind of a nifty deal. Jeffrey Snover, the creator, the godfather of PowerShell, wrote that, so it's fun to throw in there. All right, so the first thing that I'm going to do, this is a web server, right? So the basic information behind it is that we were told there's a web server that they suspect has been compromised. So the first thing we want to do is look at the kind of the file system, what's going on in the root directory, kind of grab our bearings there. Get forensics child item is similar to like a directory listing, DIR in the command shell, except what we're doing is we're parsing the MFT to determine what files belong in the root directory. The first thing that kind of catches my eye, and because this is a 15-minute demo, is the XAMPP directory, which is typically where a lot of web server type files would be residing, so I'm kind of interested in checking that out. So I'm going to get forensic file record is the MFT parsing commandlet. So all the stuff I just talked about, you don't even have to think about it. You just literally type in get forensic file record, volume name H, and it parsed it that fast, right? This is what a MFT record looks like in PowerShell. And so notice that it has a full name. The name is $MFT in this case. It tells you whether it was deleted or if it's a directory. It has a bunch of timestamps from the standard information attribute and the file name attribute. It also gives you like the parent record number, the record number for that particular file. And then there's an attribute array. And so this is that pretty picture that had the data attribute and all that kind of stuff. This is what I'm showing here in PowerShell. Notice that there's, for instance, a standard information attribute which has a number of different timestamps. The file name attribute has more timestamps. And then you have like the data attribute. That data run in particular is where the contents of the MFT are stored on the file system. So it's kind of interesting for us to check out. This is just kind of showing the structure of how PowerForensics works. All right, so now I'm going to in particular look at the data attribute, and we're going to look at the data run. So just kind of showing how PowerForensics stores those data runs. And this is telling us that relative cluster from the start of the volume, 786432, I think, and it goes for 15,600 clusters, which a cluster is 4096 in this case, 4096 bytes. And so that's just telling us kind of the size and the location of the master file table. Now, we don't care about that anymore. We're going to go ahead and whittle down the MFT, and we're going to say, hey, show us all MFT records that have a file name that starts with h:/XAMPP. And then we're going to compare, we're basically trying to whittle down, because the MFT has 62,400 records in it, in this case, usually a lot more in real life. And we whittled it down to 19,473 records just within that XAMPP directory. So we've already got rid of 2/3 of our records, just kind of giving ourselves something to look at. Now, PowerShell has like really cool grouping functions, so we can group all the records based on the file name modification time. And so we're going to say, hey, group all files and show us the different file name modification times that are associated with these XAMPP files. And in this case, we have 3 different dates that files were modified, or in the case of the file name modification time, kind of the creation time. And so we see that 17,000 were created on August 23rd. And then there's 2 other days, September 2nd and September 3rd, where there are a relatively smaller amount of files that were modified. And so what we're going to do is we're going to look at those files that were modified on the 2nd of September. Kind of the logic here is that when you kind of create a web server, a lot of files are going to be created all at once. And so let's see what's changed since they were created. And so this is going to show us, we're going to put it all in chronological order using that sort object. And then we're going to use the select object to show us the name and the timestamp. And if you notice, there's just a ton of different files. These are like the session files. So on an Apache server, every time somebody tries to access the Apache server, you're going to get one of these session files. And there's just tons of them that are created all at the same time, right? And so it looks like either we have a really busy server, or if it's maybe a smaller server, somebody's doing some sort of like port scanning or trying to do some automated access. And then we're going to look at that second group. So these are files that were changed on the 3rd of September. And we see one last session there that was created at 6:49:23 a.m. And then we see a bunch of things like webshell.zip, PHP shell, c99.php. Do a little open source research. I mean, webshell.zip, you don't really need to do that much open source research, I guess. But c99.php, if you go to Virus Total or you Google that, you'll see that there's something strange about that. But we can actually look at those files, right? We're going to parse the MFT, figure out where the data of that session is, and we can parse out what the contents of that file are. And so in this case, it looks like somebody tried to do some sort of connection using an admin username. And then we're going to go ahead and look at this PHP shell2.php. We could open it up, and here's the contents of that PHP script. And we see, there's an IP address, a port, some sort of like, connecting out via sockets going on. You could give that to, somebody that knows PHP, and they would be able to determine what's actually happening with that script. So just kind of not going to go in deep with that because of time limitations, but that's kind of an idea of something that you would be able to quickly find. All right, so a really cool thing about PowerShell is that PowerShell is built on the .NET framework, and so .NET gives us tons of capabilities, one of which is the datetime object. And so getDate allows us to create a date. In this case, I wanted to create kind of a start date of September 3rd, right, at basically midnight. And so, and then we're going to give it an end date, and there's actually a method on the start date that we just add one day. And so now we have kind of a temporal range of the 3rd through the 4th, right? And so now we can really whittle down and say, hey, show me every file that was modified between the 3rd and the 4th of September 2015. Just parsing the MFT again, and now I'm going to build a window showing, like I said, every file that has a file name modification time that falls between September 3rd at 12 a.m. and September 4th at 12 a.m. And it's going to be a much more stark contrast between the number of total MFT records versus the number of MFT records that fall within that range. And so we started with 62,400, and after that we have 22. So now we have, we kind of have like a temporal range of when some weird stuff was going on, and we have 22 files that were modified / created during that time frame. And so again, we're going to sort it based on that timestamp, and then we're going to show just the name and the timestamp. So again, a lot of these files are similar to what we already saw, but we have a couple more interesting things like the temporary internet files, which have XSS_S. We could check that out, and then we have like that IP address again. Might be something that is worth investigating. Again, the web shells kind of going on. Just kind of a different way to look at it, kind of narrow your scope there. And then you see like addriver.sys or mwdwdui.bud in the drivers directory. So, who knows what that is, but off the top of their head, but we could go check that out. So the next thing that we want to look at is the USN journal, which is the update sequence number journal. It keeps track of like file operations. Dave Cohen's the man when it comes to the USN journal, if you have any questions about it. And so this is going to keep track of everything that changes on the file system. So even more granularity of when a file is updated, when it's deleted, when it's created, so on and so forth. And so like a deleted file, you may be able to determine that it exists from parsing the MFT, but the USN journal is going to keep kind of information about that regardless of whether the MFT tells you about it. And so this is what a USN journal object looks like. We have server manager.log. It has a record number, which points to the MFT. And then we have like the parent sequence number, so we could derive the path of that server manager.log file. And we have a timestamp. And then the reason tells you what happened. Data extended means that somebody was adding data to that file. So a log file, you expect to see that pretty frequently. So again, we're going to take that USN journal, and we're going to whittle it down to that temporal range between the 3rd of September and the 4th of September. And we went from 12,429 records to about, I think, 8,000. So there's still a lot of stuff that falls within that range. And so I don't know about you, but I don't want to look at 8,000 different USN journal entries. And so we're going to use that group object function in PowerShell again. And these are all the different files that have USN journal entries, all grouped together. You see server manager.log makes up 8,273 of our like 8,400. And so you could go look at what server manager.log is, whether that's interesting or not. You could kind of put that to the side. Once you check it out, I think it has to do with like installing roles on a server or something along those lines, if I remember correctly. We see that session file that was interesting previously, that's been updated 14 times. We see that's that temporary internet file there. We also see PHP 331.tmp. So that's something I haven't seen before in before in this investigation. Here we're able to see that the file, that's the USN journal for the file create. It also gave us the record number 62330. And so group object kind of like obfuscates the actual details from you. So what we're going to do is we're going to try to actually see what those USN journal entries look like for that PHP 2331.temp. All right, and here they are. And so we can see that at 7:10:15 is when that file was created based on the USN journal entry. And then we can see that there is some data truncation there, and then data extend, and it all kind of happened all at the same time. So when file creation occurs, there's a lot of things that go on. And then we see that it was also renamed, right? And so, that's interesting. So that file wasn't in the MFT because that name doesn't exist anymore because the file name was changed. And so we're going to go ahead and store that in a variable, $62330. And then we are going to see that there's 6 of them. We're going to look at one, so that's what it looks like, that rename old. And then we're able to pivot from that into the MFT. So there's a get file record method. I clicked pretty fast, but what we're able to do is pivot from the USN journal back into the MFT, and we can see that file got renamed to phpshell.php. And then we have all the timestamps to kind of corroborate that information. Yep. And so, yeah, we rename at 7:15. We ran the get file record method, which allows us to automatically go from that USN journal entry into the relevant master file table entries. When I was making this video, I was like talking in my head, trying to make sure that the timing kind of worked out. Who knows how that went? All right, so now we're going to see what the content of that is, and if you know PHP, then that's probably, it doesn't look like something that's really good. It looks like it's going to basically allow you to run an arbitrary system command. So kind of the next thing, we found some weird PHP shell, but one thing I want to look at is the access log, the Apache access log. And so this isn't in like the GitHub version of PowerForensics yet, but just kind of playing around with some of the power of PowerShell. Excuse the bad pun. And so what we're going to do is parse that into a $access variable. And the cool thing about the C#, DLL that we're running from, it exposes all of our classes as if they're like .NET objects, and so, or .NET classes. And so like we could run the get instances method. This is what a Apache log object looks like. We have a status, we have the user agent, the HTTP method, a timestamp. All these timestamps are like a common value, right? They're all datetime, .NET datetime objects. So you can like pivot, get to the milliseconds, the number of ticks, so on and so forth. So we grouped all of these based on the HTTP method. And if somebody's writing something to a web server or got like unauthorized access, they would probably be posting data to it. And so we want to go check out all those posts. A couple different ways to look at it. That's kind of, overflow, we're getting a lot of information. But maybe an interesting thing is like that C99 PHP !act equals CMD might give us a timestamp on when somebody was issuing a command to that C99 PHP shell. See that they're using Iceweasel, which if you're a Kali Linux user, you probably are familiar with that browser or user agent. All right, so this is just a different way to look at it, kind of seeing what those refers were. So like there's some weird PHP shell or a PHP file that we haven't seen before, whether that ended up being successful or not, we don't know unless we look deeper into the objects. But just kind of a different way to look at that. All right, so this is where now we're kind of getting into the forensic timeline concept. And so like with log to timeline, forensic timeline became a very, very important thing when you're doing an investigation. Kind of helps you build out that temporal range and then do investigations. And so it aggregates all this information, the MFT, the registry, so on and so forth. So what we're doing here is we're showing what an MFT record looks like, and notice that there's multiple timestamps there, right? And so I can't build a direct timeline based on that one MFT record. So what I have is a unified forensic timeline object, which is going to like look at an MFT object and then parse out the different timestamps. So notice that one MFT record object turned into 2 forensic timeline objects. All right, so now what I'm doing is I get forensic timeline. Simple as that. You tell it what volume you want to run it against, and then save it into a variable. And it's parsing the registry, the master file table, I think the event logs, but maybe not in this case, prefetch, all kinds of stuff. And we'll show, here's the sources that we have in this case. So USN journal, registry, MFT, and then like shell link files. All right, so now what we're going to do is, again, we're going to reduce the data set from everything into that temporal range of the 3rd through the 4th. And if you want, you could just output this to Excel, but there's like 200,000 lines of information. Okay, so yeah, we went from 244,000 entries in the timeline, and by reducing it, we went to 8,700, which is a lot more manageable. And then Doug Fink, who's a PowerShell MVP out of New York, I believe, he wrote Export Excel, which is a PowerShell module which allows you to like automatically build Excel documents from the command line. And so just kind of showing that use with the timeline. So you pipe all those objects into Export Excel, it pops it up for you, and then like it's already built into a table, and the top row stays safe for you. It has all the timestamps there, and then just all the information. Trying to look as similar to log to timeline as possible, because I know a lot of people are using that, trying to kind of keep it general or keep it the same. And so that's the end of that. But that ultimately what you would do is then go through that timeline and do your investigation. And then if we go back to the PowerPoint. Back to the PowerPoint, cool. Yep, okay. So I forgot to I played the video too quickly, but client doesn't, this is the situation. They didn't give you that much information. They said, hey, we have a web server. The web server we suspect was compromised. So these are the things that we needed to do during that video, which I think we did. And then you could kind of, based on that like 15-minute investigation, we're able to say things like, hey, there's a possible attacker IP of 192.168.56.102. Looks like there's some sort of brute forcing. A little bit more investigation would have led you to think that it was SQL map. The time that it started was, of initial access was 6:49:23 a.m. There was a number of different web shells that were created on that system. So that's kind of the initial findings that you could give to your customer or to your boss. Yeah, if anybody has questions, I could be outside waiting, and we can take them offline. Thanks, guys. Appreciate it.